Hello? You there? Hello? Oh, we're on? Okay. Hey everybody. Thanks for your patience last week. Hopefully the video worked well enough for you to figure out what's going on so we can take a quiz today. Sub should have handed you a review. 1, 2, and 3, hopefully kind of looking at the videos and the review that I left the sub with the answer key. You can kind of figure those out, pretty standard, just like what hopefully the notes were in class. If you look at 4, 5, and 6 though, a little bit different, and same with number 7. So I want to do those real quick, walk you through those, and then you'll be on your own. You can try 1, 2, and 3 on your own. Make sure you have any questions, ask somebody around you. Have a little bit of time here. The quiz shouldn't take much more than probably 20 minutes. Okay? All right, here we go. Okay, as soon as this focuses, we'll start. All right, I'm trying to video camera so the picture is a little better and the audio will be a little bit better, so bear with me. Apparently I wrote these in by hand, and I don't necessarily remember what these numbers were, but that shouldn't impact how we could do this. So what this is saying is use the graph of the function shown below to answer 4 through 6. So if you kind of look at 4 through 6, we're going to use this graph to answer those 3. Hopefully from the video that you watched last week, we have equated the idea of this f primed of x, that's one of the notations for a derivative, that this means slope. It's kind of a fancy way of saying the slope formula. Alright, that's what a derivative means. So in number 4, when it asks where is f prime negative, since this is the graph of f, if they're asking you where f prime is negative, it's basically just saying where is the slope of that graph negative. So hopefully we kind of remember just with lines over the years that a positive slope means your graph is going up. If it's a negative slope, your line would be going down. That's what it was with a line. Well, it's the same with the function, same with a derivative and with a curve. So if this is saying where is the derivative negative, it's basically asking where is the slope of that graph negative. So it's just going to be wherever this graph is going downwards, just like it would have been in a line. So if you look at your graph, you have to look at your paper for the actual numbers. The answer to number 4, if you just kind of look to see where that graph goes downwards, would be that interval in which we are either going up or going down. So in 4, where it says where is f prime negative, okay, my phone's ringing just as I'm doing this now, so just ignore that, okay? Let me see if it's important actually. Hold on. Okay, we'll get in a minute. So where is our derivative negative? It is negative when our graph goes downwards, because that's where we would have a negative slope. So starting here, our graph is going down, so we'd have negative slopes throughout here. The whole idea of a line tangent, any tangent line drawn to this graph is going to have a negative slope. So whatever this number is to whatever this number is the interval where we would have a negative slope. Okay? We also have a negative slope from here to here, because this again is where our graph is going downwards. Alright? So in terms of where is f prime negative, we're going to write this in interval notation. If you remember, interval notation is like parentheses. So like parentheses mean it's an open interval. Bracket means it is a closed interval. We're going to use this notation. So it's going to be from whatever this number is, and again, you're going to have to look at your paper to figure out what that number is, to whatever this x value is. That's where you're going to have a negative slope. These need to be open. They need to be parentheses. Okay? You're going to do a union. We should also have a negative slope right here, because this is where this graph's going to go down. So the second answer to this would be from this number to whatever that number is. That's where the slope of our graph is negative. Okay? 5, where is it positive? It would just be the opposite. So if you look at your graph, it's wherever that graph is going upwards. Okay? That graph is going upwards from here to here. So if I have lines tangent, the whole idea of a derivative is the slope of the line. Tangent is the slope of the curve. We're going to have positive slopes here. So starting at whatever this number is in your paper to whatever this number is. And again, these would need to be parentheses, and I'll explain the parentheses a little further here in a second. Union. We also have a positive slope starting here and ending here. So whatever this number is to whatever this number is, our graph is going upwards. So any line tangent here would have a positive slope. So we would have two different intervals of time for both of these. So slope negative, we go down. The derivative positive, slope positive, you're going to be going up. Where is your derivative equal to 0? Well, you're going to be 0 at the highest point here. That's when we're not increasing or decreasing, and our line tangent would be a horizontal line, and the slope of horizontal lines is 0. So whatever this x value is, you're just going to say at x equals this number. Also, at whatever x value this is, this one. So there should be three different answers here. All right, and again, I don't know what those are, but you're just going to write x equals this, x equals second one, x equals the third one is going to be these three right here. Okay, so that's it. Last one, use the table below to answer question number 7. 7, it says find an approximation for f primed of 10. All right, f primed is a derivative, and since it's an approximation for a derivative, if you can kind of look here, the approximation for a derivative, that means you're going to use your slope. That's what the slope does. It approximates our derivative value. Since it's f primed of 10, that means we want the derivative value at 10 or the approximate slope at 10, the x value of 10. So what you need to do, go to your table, look at the x row. So the top row is your x row. Over here is the x value of 10. We want to approximate the slope at 10. Well, the slope is your regular old, in terms of average rate of change, it's just the change in y over your change in x. So the f primed of 10, we're just going to do change in y over change in x. Since this is the x value that we're approximating our derivative at 10, if remember, hopefully from that video the other day, we can use the slope of 2 points, but the closer we get to the point that we want, the closer the approximation is going to be for 10. So we could do change in y from here and here over the change in x from here to here. Find the slope of these 2 points. We could do the slope of these two, but if we're trying to approximate f primed of 10, we want to use the point closest to the point that we are trying to find. So it would be these two. So the change in y around 10, we're not going to actually use a value of 10 at all. We're going to approximate the slope at this point using a secant line through the 2 points directly in front and directly behind. So our change in y, the second row here is your y values. So you're going to do 6 minus 13 over your change in x's. The top row was your x's, so 14 minus 8. So this will give us a negative 7, 6. That is your approximation for the derivative at x equals 10. All right, let's throw down an 8 just to make sure we understood that. Let's say I wanted you to find an approximation for f primed of 5. All right, what that would mean is you need to look at your table, find where the x coordinate is a 5, and we want to approximate the slope at that point. So here's where x equals 5, and what we need to do to find the slope there is just do the change in y over the change in x for the point closest to this particular point. Or the closer you are, the more accurate it's going to be. So if this is the point we want, the values you're going to actually use for your slope would be this point and this point. All right. So these are going to be the two that we use for the approximation. So again, you're going to do the change in y over your change in x around around that point that we're trying to find, x equals 5. So in this case, your change in y would be 13 minus 10. At these 2 points, your change in x would be 8 minus 3. All right, so that would give you 3/5. Okay. All right. Look those over. You have a little bit of time. The sub should have the answer key for the rest of these, so look that over. Hopefully that is clear, and the quiz should take you about 15-20 minutes. So good luck, and we will be seeing you soon. All right, bye.